Hey guys, and welcome to part 18 of my pre-algebra tutorial. I'm sorry. In the last part, we went over additive properties, and before we begin, I just want to write a couple additive properties on this board, so to speak, and I want you to tell me, I'm going to give you like an example, like here, right here. I'm going to give you an equality. And I want you to tell me which property this is demonstrating. This is, if you guys are taking a pre-algebra course at school, this is the kind of format that your test is probably going to be in, and yay for world's ugliest line. So just think about them and do them while I'm writing them. That's wrong. It's very, very silent right now. I'm just writing a bunch of them. And I guess I'll do one more. Let's see. Okay. I'm going to give you... Pause the video right now if you guys aren't finished, actually. So as you can see, since we're associating these numbers differently, we're placing parentheses around 1. We basically are saying associative, because you can either, we're just basically saying that you can associate the numbers differently. A plus 0 equals A. Well, the 0 and the identity, like I said in the last part, are actually almost like they are the same thing as far as addition is concerned. So there is no point in really saying either or. So 0 or identity will work for this one. A plus B equals C plus A plus B. Well, that's commutative, because if you recall, commutative means it commutes or moves. Let's see here. A plus C, people say that's another commutative. I don't know why I wrote two commutatives. And A minus A equals 0. This is the inverse. Or is it? Correct. This wasn't actually a real property. This was A minus negative A equals 0. Now it becomes the inverse. I just wanted to see if you guys could catch that, or if you guys are just... it wasn't because I messed up or anything. No, seriously, it wasn't because of that. Awkward. Anyways, we're gonna move on. All right. So today we're gonna go over the multiplicative. Multiplicative, the world's most hardest word to pronounce. Okay, let me see if I do this right. Multiplicative. Okay. Oh, nope. Yeah, and that's B's okay. Okay. Anyways, so like in addition, there's the 6 of them, so I'm just going to type them all up now in this really small font. Associative, there's commutative, there's, whatever, I don't need to type them. There's associative, there's commutative, there's identity, there's inverse, and there's the 0 property. Let's take a look at all of them, alright? Let's go. First up, we have the commutative property, so commutative. Now, as you might recall, multiplication isn't exactly written as A times B times C, because this times sign really confuses us, because in the world of algebra, we use X a lot. I don't know whose genius idea that was, but anyways, and, we could always do the dots, but mathematicians basically decided you can just write them next to each other and we'll understand it. So let's say we have the A, B, C, D. Commutative, in addition, if you recall, says we can move around or commute. And multiplication basically means the same way. So we can move these around in infinite ways, and they all mean the same thing. So remember, as long as you have the 4, so I'm going to make it 2 different colors, or a couple different colors. Oh, you can't really see that yellow. Whatever, so as long as you have the 4 colors in all locations, blah. Yeah, anyways, whatever. So as long as you have these 4 numbers in all 4 of your equality thingies, you're going to be fine as far as commutative goes. Next up, we have the associative. Now, take a moment if you could recall what it does in addition. It basically says that A, B, C, D So you want to multiply AB first. Well, you don't have to. You can also multiply BC first. Doesn't matter which two you multiply first, as long as all four wind up getting multiplied. And you can even simplify it, because if you know the value of B would be 3 and value of C is 4, in this one it'd be, well, this is a bad example. You know, if it was like 3BC5, you knew the values of A and D, it'd be a lot simpler if you could just move these around and say, hey, why don't I just multiply this to that? Well, using the associative property, you can. So that's the associative property. Next we have the identity property. Now the identity property in addition states, let's say we had 6 like we had last time. We want to get 6 on the other side. We want to multiply something by something. What can we multiply it by in order to get 6? Well, according to the identity property of multiplication, if you multiply any number by 1, you're going to get that number. Let's think about this logically. Remember back in elementary school when they taught you multiplication, they taught you rows, like 7 times 6 was 1, 2, 3, 4, 5, 6, 7 times 1, 2, 3, 4, 5, 6, and you have to dot them all in, and then you counted it, and then in the end you wound up having 42 or whatever, I don't care. Yeah, it was 42. In a similar manner, this is 6, and we want to see how many times we have to write 6. How many rows of 6 we need to just get 6. Well, logically speaking, I drew 7. Never mind. Logically speaking, only 6 dots would really be needed to get you 6. So 6 times 1, that 1 will get you 6. Which makes you probably wonder what does the 0 property mean in multiplication then? Well, 6 times 0, if you multiply something by 0, you always get 0. Always, always, always. Because it's like saying in that row, this is the box that's going to contain the rows, we want 0 rows of 6, or 6 rows of 0. Alright, you got it. It's going to be 0. 0 is the total quality. So, multiplication, 0 versus identity. 0 and identity are different. The identity property states you multiply by 1. 0 says you're going to get 0. So that's where multiplication and addition really differ. Now, the inverse property of multiplication, this is where it starts getting a little shaky. But let's just think about this. Let's say we want to get to 1, because the inverse is always going to have to be 1. And let's think about why real quickly. Let's say you had A, B, C, D, but you want to cancel out B. Well, if you have 0, as we just learned, the 0 property means that you're going to get 0, and then the entire thing is going to wind up being 0, because 0 times anything, as we learned in the 0 property, will wind up being 0. Does that make any sense? If not, rewind that and just think about that. So what we really want as an inverse, if you want to cancel out multiplication, is we want it to be equal to 1. Because if it's equal to 1, we can just ignore this coefficient, and then we've effectively gotten rid of that variable. So what can we multiply to 6 to get it equal to 1? Let me draw a picture of something for you. And I'm a terrible drawer, by the way, so... Alright, so let's divide that into 3 halves. This is really bad. And that should be 6. 1, 2, 3, 4, 5, 6. Okay. Let's say I'm going to color it in red, because red is... red? What am I even talking about? Red. I meant yellow. Let's say let's draw up this pie. It's a yellow pie pizza. Don't eat the pizza, kids. So this is the entire thing. We have the entire thing. But we just want 1. So we want to take 1 of it. We want to take 1 out of the 6, which would be this thing right here. Just 1 of it. But how many is left? 5, 6. So really, we're only taking 1/6 out of it to get 1. I don't know if that maybe confused you more. Yeah, if that confused you more, I'm gonna think this in a better way. So 6 times 1/6 equals 1. Remember back in elementary school when you learned, 6 is really 1 over 6? And then what you can do is you can basically divide out and, simplify. If something's on top left from these two things, you can simplify them. Divide by 6, divide by common thing, get 1. This works with anything. A times 1A will therefore net you 1. So the inverse property, that pie probably was not a good idea, because I'm having made some of you guys hungry, and others is probably confused more. So the inverse property states that A times 1 over A equals 1. So as long as you add a 1 over the number, so how would you get 1 out of 7 if you had to multiply something? multiplied by 1/7 equals 1. Now, a cool thing about this while we're on this topic is, let's say we wanted to get 2. Well, as you know, these 7s on the bottom, if they're on the bottom, they're going to wind up canceling out. So if we just write 2 7s, we multiply by 2 7s, we only get 2. So we're basically taking 2 7ths of 7, and that's going to get us 2. I hope that made sense. I believe I went through all of them, actually, now. Let's review. Commutative property of multiplication. A, B, C, D equals D, C, B, A. You can move, commute, move. Associative multiplication. You can associate them in different ways. Let's say we have AB equals CD. Well, we can also do A, B, C, D. Let's see, we went next to 0, and 0 is different in, there was no need to do that. The 0 property of multiplication is different, not Xerox, because I even spelled that wrong. If you multiply something by 0, you're always going to get 0. Oh, not 6, 0. Always going to get 0. Let's move on to the next, identity. To get 6 on the both sides, and you want to multiply something, multiply by 1. 1 is the identity number of 6 of multiplication. If ever you need to get the same number on both sides, and you want to multiply by something, multiply by 1. This is in contrast to addition. If you recall, you want to add nothing to something to get 6. You want to take one row of something if you want to get 6. So think of bushels of gumdrops for addition. Bushels of gumdrops. That was an ugly D. And think rows, just rows. Look at that, because multiplication's ugly. So bushels of gumdrops for addition and rows. Okay, so identity, basically, like I said, you want to get 6 on both sides. You want to multiply something, multiply by 1. So we covered identity. And lastly, inverse. The inverse basically states that if you want to get 1 on one side, it means we want to completely negate something, multiply by 1 over something, and that'll negate it. Alright. Little note on the inverse property. In case you guys are rewatching this tutorial, which I guess you might want to, if you completed this tutorial and coming back, a little look at the inverse property. You guys can move on to the next tutorial part unless you want to stay here. I mean, it might confuse you guys. The inverse property isn't necessarily saying 1 over a. In reality, as you recall, you know, a to the first power is always going to let you the 1, and we want to basically get 0 and 1 plus, and remember the negative, the exponent rule. Basically, you want to take a to the negative first power. That's what the inverse multiplication says. Basically saying take a number to the negative first power, and that will get you 1. So instead of saying 7 times 1/7 equals 1, we're really saying 7 to the first times 7 to the negative first, which is going to negate to 7 to the 0th power, which is, if you recall, is going to be equal to 1. And I'm telling you this because when we have stuff like 1/7, we're going to want to first rewrite that into 7 to the negative first, and then multiply that by the inverse, which is going to be 7 to the first equals 1. So 1/7, the inverse of this is going to wind up, if we do that, we're basically squaring it. So you always want to multiply by the opposite of the charge, I guess, so to speak, of the exponent. So let me just do another one. Again, it might blow right through your mind because, so 8 to the negative first, which is basically like saying 1 over 8. We're going to multiply that by 8 to the first to get 1. So opposites charges. Also works for 8 to the negative. Nah, never mind. Too complicated. Not really. Negative, blah, blah, blah. And that's always going to equal to 1. So always multiply by the opposite. And that does it for multiplicative properties. In the next part, we're going to go over the distributive property. That's going to be intense. Alright, that's all. See you.